Hi, welcome to today's lesson. We'll be talking about writing chemical formulas today of elements. Um, Steps to write chemical formulas effectively. First, you need to identify the element present in the compound for which you want to write the formula. You can use the periodic table or previous knowledge. You have to determine the valencies or oxidation states of the element, either from a chart or from previous knowledge. When it comes to writing chemical formulas, the more you know about this, the easier it is. You wouldn't want to be looking for a chart or a periodic table each time you need to record the formula of a compound. So there are tricks that would enable you to recall valencies, oxidation states properly and promptly. So we'll be talking about those tricks as well as we proceed. And then also you need to balance valencies whenever you write chemical formulas. So these are the steps that you can use to write the formula of compounds. Okay, how do we write chemical formula? We use the symbols of the elements that are present in the compound, and then for their relative amount we use subscripts. If one element is in the ratio of, if the elements are in the ratio of 2 to ratio 1, the one that has the ratio 2 has the subscript 2, and then the one that has the ratio 1 has the subscript 1. But when most times we don't indicate when it's just when the subscript is 1, it is taken for granted. So if the valencies are the same, you just write, there's no need to put subscript. But if the valencies are not the same, the subscript becomes important. The valencies becomes the subscript, the oxidation state becomes the subscript, as we will soon see. So there are times that one need to cancel out as required. So take note of all these rules, because when we start writing chemical formulas, or when we start, illustrating how chemical formulas are written, we will be needing them. Okay, for example, sodium chloride. If you have not watched my video on electronic configuration and valencies, or how to determine oxidation states, you can do well to watch them, because I will not be going into how some valencies are determined. So watch that video and then you will get to know how the valencies can be determined. Okay, sodium chloride, the oxidation state of sodium is +1, and then the oxidation state of chlorine is -1. So if you have to write the valency, you can crisscross as is shown here. Sodium takes 1, chlorine takes 1, but once their valencies are the same, no need, just write the formula together: sodium chloride NaCl. So it's very important. Oxidation state can be gotten by electronic configuration. Also watch my video on that, and then you would understand better. Okay, magnesium chloride, the element present are magnesium and chlorine. Magnesium is Mg, chlorine is Cl. So the oxidation state of magnesium usually is +2, and then chlorine is -2. So because they are not the same, we crisscross. So 2 1. So once we crisscross, this 2 goes to chlorine and this 1 goes to magnesium. So magnesium chloride is written as MgCl2. So it's very, very important that you take note of this. And then the next is aluminum oxide. The elements present are aluminum and oxygen. Aluminum is Al, oxygen is O. So the oxidation state of aluminum is Al and oxygen is -2. So once we use the crisscross method, Al is 3, O is 2. So once the crisscross, this 2 goes here and then this 3 comes here. So our aluminum oxide is written as Al2O3. So that's how we write chemical formulas of compounds. So in the previous illustration, the elements involved there were elements involved. So sometimes you could have an ion that's made up of more than one element reacting as a single unit, and then those ones have their oxidation states as well. Remember, they are reacting as a single element, so you don't see them as individual elements. Very important. So in chemistry, most of the ions that you come across with a -1 oxidation state or a +1 oxidation state are these. It is very necessary that you practice them: nitrates, nitrites, hydrogen sulfates, hydrogen sulfides, and so on and so forth have an oxidation state of -1 because they react as well, and then they form formulas, and then once you're writing the formula, the ease with which you remember the oxidation state is very important. So remember, ammonium is the only exception here that has +1. All of them here have -1. And then polyatomic ions with oxidation state of -1 continued. So chlorate, perchlorate, cyanide, hydroxide. You meet all these in various compounds in chemistry at this level. And then those with -2 and -3 are shown. So I would just advise you memorize those with -2 and -3, and then any other one is -1 because they are not much. And then once you memorize them, it will be easy to write formulas subsequently. Okay, so let's write the formula for bases. Bases usually have the hydroxide ion. Hydroxide ion has a charge of -1 or an oxidation state of -1. It's very important. It's one of the polyatomic ions I just mentioned. So for example, sodium hydroxide, the elements involved are sodium and the hydroxide ion, so it's treated as an element now. So the valency oxidation number of sodium is +1, and then hydroxide is -1. So this is already balanced, so just write them as NaOH, and then that's the formula of sodium hydroxide. Very important. And then the next is calcium hydroxide. Identify the ions present. The ions or the elements present: calcium and then hydroxide. Remember, calcium is +2, and then +2, and then hydroxide is -1, as we've said earlier. So because their valencies are not the same, you crisscross. This comes here and then this goes here, so it's Ca1OH2. Remember to put the OH in parentheses because remember we said they are reacting as a single unit. If you put the 2 beside the hydrogen alone, it will be as if it's only the hydrogen that is 2, but OH is reacting as a single entity. So it is important they are in parentheses, and then the 2 is written by the side. Basically what this means is to neutralize the +2 charge on calcium, you need 2 hydroxide because each hydroxide has a -1 charge. One can interpret it that way. It also makes sense. Okay, the next thing is writing formulas for salts. Salts are formed when acid and base react. Sodium chloride, we've done that already, is a salt. I want us to consider other salts. Calcium sulfate, talked about sulfate. It's one of the polyatomic ions we mentioned. The valency is -2. So calcium +2, sulfate -2. So they balance. So just write the formula. If you choose to crisscross, at the end of the day, you get Ca2SO4 2. Once they are equal like that, you can usually cancel out. The two cancel out. But the easiest way to understand it is once they are equal, no need to crisscross. Just write it out. Okay, acids. Acid salts rather are formed when when an acid is partially neutralized by a base. So they usually contains this ion. I will call them acidic radicals. So for these acidic radicals, one of the polyatomic ions we mentioned earlier, the charge, the oxidation state is -1, as we've already discussed, and then sodium in this case is +1. So their charge balances out. So the formula is NaHSO4. Basically, this is sodium hydrogen sulfate. Okay, sodium hydrogen carbonate, the same thing. Acid radical is -1, and then sodium is +1. So the formula becomes sodium hydrogen carbonate. So take note. So do well to practice using the chart that I have provided, and then write the formula of the following compounds. So these are, sorry, let's see if I can go back. Yes, this probably you didn't get this very well, so take note. This is the this is the second one, this is the first one, and then this is the second one. Pause the video and practice writing them. And then this is their formula. So hope you got them correctly. So if you didn't, you can watch the video again for more understanding. So more compounds and then more formulas. Thank you.